Hello everyone. So today we are here to learn about the topic of balancing chemical reactions, and before starting to tell you the details about all the procedure, I want to make you know I want to make you acknowledge about the fact that this method of reaction balancing is pretty large and it's somewhat time consuming, but this method will work for all methods of this method will work for all chemical reactions, and no matter how small or how large, how easy or how complicated the reaction is, the method will work. Okay, so welcome to the video in favor of Science A and Science Academy and SKILLSHARE education. Okay, SKILLSHARE education. So okay, so let's get started. All right. Okay, so a balanced chemical reaction. What do you mean by a balanced chemical reaction? A balanced chemical reaction actually means two things. That means the moles of the reactant and the product side will be balanced, and number two, the charge, if any charge is present, then charge on both the reactant and the product side has to be balanced. Does a reaction actually contains charge? Yes, indeed, the reaction sometimes contain a lot of charge in both the reactant side and the product side. So let's begin. Okay, let's see. So let's start with a pretty easy reaction, like I'm talking about, for example, hydrogen plus oxygen. This will give you H2O. Now what you have to do is that you can put letters beside it. I'm putting letters A, B, C. These are basically the mole numbers. Okay, so here look, hydrogen has got no charge at all, oxygen has got no charge, and water has got no charge. Okay, so these things, none of them has got any charge, so there is no hassle of balancing charge. We just need to balance the moles. So okay, now if you talk about hydrogen, look, in the reactant side we have number of hydrogen as 2 into A, which is 2A, and in the product side we have 2 into C, which is 2C. So 2A must be equal to 2C, so 2A must be equal to 2C in case of hydrogen, and in case of oxygen what we have is that, look, 2 into B, which is 2B in the reactant side, and in the product side we have 1 oxygen, so 1 into C means C. All right, so these are the things that we have got. Okay, now we will put it all together. We will choose numbers to find the values of A, B and C. Whatever numbers you choose, the reaction will be balanced. Okay, for instance and for simplicity, I am choosing B is equal to 1. Okay, so if I choose B equal to 1, then C will appear as 2. For example, B equals to 1, and so C will appear as 2 into 1, 2 into 1, which is 2. Okay, and since 2A equals to 2C, since 2A equals to 2C, that means A must be equal to C, and C is equal to 2, so A must also be equal to 2. Okay, so we have got B equals to 1, C equals to 2 and A equals to 2. So let's now put it all together. We can say that 2H2 plus 1 O2 or simply O2, this will give 2H2O. It is not necessary that you have to take B equals to 1. You can take any number you like. It won't be a problem. Any number, it can be any number you like. No problem at all. Okay? So this is how we are balancing this reaction. Okay, now let's look to a reaction which has the theme of both mole and charge balance. All right? Okay. Okay. So let's look at this equation, like Mn plus 7 plus Fe plus 2. This will give Mn, what's going on? Mn plus 2 and Fe plus 3. All right? Okay. Now let's put numbers. Okay, so I put here I put here A, B, then C, then I put here D. Okay, so here we go. We have to balance both the mole and the charge. Okay, so first of all, let's talk about mole balance. Okay, so here we have 1 manganese, so 1 into A is A, and here we also have 1 manganese, so 1 into C means C, so which means A must be equal to C. Now talking about iron. Okay, so here is 1, so 1 into B is B, and here is also 1 iron, and 1 into D is D. So A must be equal to C and B must be equal to D. So this is what up to the moles. Now let's look at the charge. Okay, now let's look at the charge. Okay, CHARGE, charge. Okay, now what we are here up to, so 7, so here is 7 positive charge, so positive 7A or simply 7A plus, in the reactant side we have 2B again, 2B, all right, and this must be equal to, in the product side we have 2 into A, that means 2A, and we have 3 into D, sorry it's C, right, it's C, sorry it's C, 2 into C plus 3 into D or 3D. Okay, 3D. So what we have is that A equals to C, B equals to D, 7A plus 2B equals to 2C plus 3D. Now let's take any one of the values as 1. Okay, so I am taking A is equal to 1. All right, then C must be equal to 1. Okay, so A equals to 1 and C equals to 1. Now let's put it together in this equation, and we must keep in mind that B is equal to D. Okay, so what we can have is 7A, which means 7 into 1, that means 7 plus 2B, I am putting it as B, 2B, this must be equal to 2 into C, C is equal to 1, so it is 2, and 3 into D, and since D and B are equal, so I am putting here B, 2 plus 3B. All right, now let's solve it. Now if we solve it, then B will appear to be 5. Okay, So we have got the values. So B will be equal to 5. At the same time, D will also be equal to 5. So we have A and C as 1, A equals to 1, C equals to 1, and B equals to D. That means if B is 5, then D is also 5. Okay. Now let's put it together. So we have 1 Mn plus 7 plus 5 Fe plus 2. This would give us 1 Mn plus 2 and 5 Fe plus 3. So this is our final balanced reaction. All right. So here we have, here we go, look, we have our both charge and as well we have both the charge and the what can you say, we have the charge and the mole, both are balanced for the reaction in this case. Okay, so I think we should look at some more and more examples. Should we go to some like organic reactions or some more complicated reactions? Okay, let's browse. No. If I go for browsing right now, then lot of messages will appear. Okay, so let me look for some reactions. Okay, so let's look at a reaction like this, which is Hi plus H2SO4. This would give no, I don't like this reaction. I hate this reaction. Let me give some more complicated. Cl2 plus NaOH. This would give you NaCl plus NaClO3. This is 3, all right. NaClO3 plus H2O. Okay. So this is the overall reaction. Now let me put some numbers, letters, sorry. It's A, then B, then C, then D, then E. Okay. Now we will carry out the balancing. Okay. Now if we consider chlorine, here it is 2A in the reactant side, 2 into A. Okay, look at the chlorine in the reactant side. Now look at the chlorine in the product side. Here is 1 chlorine, so 1 into, here is 1 chlorine, so 1 into C is C. Here is also 1 chlorine, so 1 into D would give D. So 2A must be equals to C, 2A must be equal to C plus D. I would suggest you to write this in your copy, because I won't be keeping these things here for long because I need space. Okay. Now talk about sodium. In the reactant side we have 1 into B, which is B, and this must be equal to number of sodium in the product side. So it is, here is 1 sodium is here, so 1 into C, that means C, plus then 1 sodium is also present here, so 1 into D, this means D. So B must be equal to C plus D. Okay. All right. Okay. Now let's go to oxygen. Okay. Oxygen. So here is 1 oxygen, so 1 into B is B. Here is 3 oxygen, so 3 into D. So 3 into D is 3D plus, here is 1 oxygen, so 1 into E means E. So B must be equal to 3D plus E. Now talking about hydrogen, so in the reactant side we look at the here, so 1 into B is B, and this must be equal to, here is where in the water, okay, water there is hydrogen, so 2 into E means 2E. So B must be equal to 2E. Okay, so from where we should start? We should start at somewhere. We should start, okay, now let's give a check. So 2 into, but chlorine, 2 into A is 2A, and here is C, here is D. Okay, talk about sodium. So B must be equal to C plus D. Okay, all right. Okay, here, look, we have B equals to 2E. So we might start from here. Okay, let's take B is equal to 2. Okay, we are now solving it. Let's take B is equal to 2. So if B equals to 2, then E must be equal to 1 from the solving. Okay, now let's put these values here in this equation. So putting B equals to 2 and E equals to 1, we have 2 equals to 3D plus 1. That means D must be equal to 1 by 3 or 3 over 1. So we have got two values. Okay, so we have got B, we have got A, we have got D. Now we can find C easily, isn't it? So from this equation we can find C. Okay, so C is equal to B minus D, isn't it? C equals to B minus D. That means 2 minus 1 by 3. 2 minus 1 by 3, which will be equal to 5 by 3. Okay, so we have got C. Now we have got B, E, D and C. So we have got all of them almost. Now let's put it into this equation of chlorine. To find the value of A, let's put the values of C and D. Now if we put the values of C and D, C is equal to 5 by 3 and D is equal to 1 by 3. Since 2A equals to C plus D, here 2A equals to C plus D, so, and C plus D is this, isn't it? So 5 plus 1, 6 divided by 3, which is 2, and that means 2A is equal to 2, which further means A is equal to 1. Okay, so we have got all the values. We have got A, we have got B, we have got C, we have got D, we have got E, we have got all the values. Okay, now if you put these values into the equation, so 1 Cl2 plus what was B? B is 2 NaOH, this would give you then C the value is 5 by 3, so we can have 5 by 3 NaCl plus, what's the value of D? The value of D is 1 by 3 NaClO3 plus, then E, the value of E is 1, then we have 1 H2 O. Okay, so this is our reaction balanced already. Now if you think that you are disliking these fraction values here, the 3, so try multiplying both sides of the equation by 3, and the fraction values will be removed into 3. So when you are multiplying 3, what you will get is that 3 Cl2, yes, 3 into 1 is 3, and 3 into 2 is 6. So plus 6 NaOH, this will give, so 3 into 5 by 3 gives you 5 NaCl, plus 3 into 1 by 3 gives 1 NaClO3, plus 3 into 1 here gives 3, so 3H2O. Okay, so we have looked at one more example. Now let's look at some more complicated example that involve the rigorous inclusion of moles and charge. Okay. Okay, so let's look at some more examples. Like I say, Cr2O7 2 minus plus H plus and plus Fe2 plus, this would give Cr3 plus and Fe3 plus and H2O. Okay, so this is the reaction. Okay, so now let's put letters. Here I put A, here I put B, then C, then D, then E, then F. Okay. Okay, all right. So I'm saving it. Okay. Okay. So now we need to balance the reaction. So look, first of all, if we talk about chromium, then what is here? Then here is 2A, isn't it? And here is 1 chromium, so it should be equal to D. All right, it should be equal to D. It should be equal to D. Okay, so first of all we are writing that okay, I forgot it again. Let's see. So what's that? It is 2A is equal to D. Okay, so 2A is equal to D in case of chromium. Okay, let me open something other so that it can easily do it. Okay, what is equal to 1? Okay, so here we have 2A is equal to D in case of chromium. So I'm writing what? That for chromium 2A is equal to D. Okay. Okay, then from here, now if I talk about oxygen, so here is 7 and here is A, so 7A in the reactant side, and the product side there is 1, so 1 into F, that means F, so 7A must be equal to F for oxygen. So for oxygen, 7A is equal to F. Okay, now let's look at hydrogen. So here is 1 hydrogen, so 1 into B, isn't it? So it's B, and here are 2 hydrogen, so 2 into F means 2F. So for hydrogen B, so for hydrogen B is equal to 2F. Okay, for hydrogen B is equal to 2F. Okay, done. Now for now iron. So for iron, here is 1 iron, so 1 into C means C, and here is 1 iron, so 1 into E means E. So C is equal to E for iron. For iron, C is equal to E. Okay. Okay. So these are the moles. Okay. These are the moles in general. Now we will look at the balancing of charge. So charge. So in this side, look, we have 2 into A, minus 2, sorry. So minus 2 into A, which means minus 2A. Then we have plus B. Then we have plus 2C. All charges has to be added up together. So minus 2A plus B plus 2C in the reactant side. Minus 2A plus B plus 2C. So for charge, minus 2A plus 2B, what? Plus, oh, I'm so sorry. So minus 2A so minus 2A plus 2B plus, what is there? So minus 2A plus B plus 2C, sorry. Minus 2A plus minus 2A, then plus plus B plus 2C must be equal to then we have D into 3, that means 3D, E into 3, that means 3E, plus nothing. Okay, here is no charge at all, no charge. So 3D plus 3E, okay, equals to 3D plus 3E. Okay, so that's the thing. Now we are going to solve all of this together. Okay, so what I'm doing is that I'm discarding this thing. Okay, so 2A equals to D, 7A equals to F. So what if I take A, what if I take A is equal to 1. So if I take A equals to 1, then D and F will give us some whole numbers. Okay, so if I take A equals to 1, then D must be equal to 2, D must be equal to 2, and talking about F, F must be equal to 7. Okay, so F must be equal to 7. Alright, and now if F is 7, look at hydrogen. If F is 7, then B will be equal to 7 into 2, 7 into 2, which means 14. So B will be equal to 14. Look, we are getting all numbers one after another. Now we are still left with E and C, isn't it? But we have got all the values. We didn't get C, we didn't get E, but E and C, they are equal, so we can put the values here and solve the equation to get either E or C. So minus 2A plus B plus 2C, let's write it down. Okay, minus 2A plus B plus 2C, this must be equal to 3D plus 3E. This must be equal to 3D plus 3E. And what we have got? We have got A equals to 1, B equals to 14. So let's put the values of A and B. We have got A equals to 1, B equals to 14, isn't it? So minus 2 plus 14 is equal to, oh no, sorry, plus 14 plus 2C must be equal to 3D plus E. What the value of D we have got? We have got D equals to 2. So if D equals to 2, then 2 into 3 is 6, plus, and we know that E and C are equal, so we are replacing E by C. So okay, now solving this equation, you would get let me see, 12, so 6, so you will get C is equal to 6, hopefully, if I'm not wrong. So 6, okay, so C is equal to 6. Okay, so these are the values we are getting. So C is equal to 6, and E, it is also is equal to 6. Okay, now let's put these values all together. Now let's put these values all together in a single scenario. So A, what was the value of A? A is equal to 1. Okay, so 1 Cr2O7 2 minus, plus, then we have B H plus, isn't it? So B is 14, so 14 H plus, and C was iron, so C is 6, so we have got C as 6, isn't it? So 6 Fe2 plus, this would give D, it is 2 Cr plus 3, then we had E Fe3 plus, E is 6, A is 6, so 6 Fe3 plus, we have got FH2O, the value of F is 7. Okay, so 7H2O. Okay, so this is the balanced equation we have got. Now let's look. So this is the balanced equation, and this was our plan. All right, so that's all for balancing reactions. I hope you like it, and you can carry on for some more practice of balancing equations, which I will be giving soon by tomorrow as a worksheet, and I will give you the link from where you can download it, no problem. Till then, if you find any problem, please inform me in the comment section. Thank you everyone. Thanks a lot.